So a few weeks ago, Simone Giertz, the queen of shitty robots here on YouTube, made a video talking about the Giertz store, which is her online e-commerce channel, and talking about the challenges that she was having within it about having it scale up and hit profitability. But there were a few things that she brought up that I thought actually could probably be solved with 3D printing. So we went ahead and just kind of made a demo and are going to talk about it a little bit more here today. So if you haven't seen Simone's video, I recommend going over and checking it out. She walks through the challenges of being a YouTuber and trying to break into product and create a product-based store in order to create redundancy for your income streams, because YouTube be fickle gods, and sometimes your videos get lots of views and sometimes they don't. So having a secondary source of income is really important in order to be sustainable on YouTube. And for Simone, that's been the Giertz store, where she has been able to produce a number of different products that are really nifty within brand and that she can sell to people who view her channel. But within that, she's run into all kinds of challenges. And most of those challenges have come around her clothes hanger, which is a custom designed invention that she created in order to allow shirts to be hung up against the wall if there's not enough room on a traditional coat hanger. Throughout the video, she spoke about a number of the challenges with that. Everything from R&D costs all the way up to having to store the stuff in a warehouse if you don't sell it all. So let's go ahead and start with R&D first, and then we'll get into the production a little bit down the line. But with R&D being such a big expense, it's largely due to how long it takes to create the products. When you're creating a product to be manufactured, injection molded, machined, so on and so forth, there are a lot of rules that have to be followed and a lot of expertise that has to be used in order to get those created. That expertise is very expensive, and there's not really a way to prototype at home. Whereas with 3D printing, you're able to prototype on your printer, and then yes, there's some translation into production and some optimization that has to occur, but you can generally go fairly quickly from a home printer to production 3D print farms like ours. With R&D with traditional manufacturing, there's not. You design it in CAD and then you send it to the manufacturer and say, can you make this? What will it cost? And they say, it'll cost $50 for that. And then you make a little tweak and they're like, oh, now it's $10. That kind of a thing. So it's a very slow process, and you have to kind of know the end result without being able to iterate to that end result, because it's just really expensive. Additionally, Simone talked about the fact that with these manufacturers, in order to get something made, you have to commit to a large volume, which means you're now spending a whole bunch of money to get stock in, and you don't necessarily know if that stock will sell. In her video, Simone talked about having to do pre-orders for the clothes hanger because they have to know how many they need in order to be ordered. So they can talk to their manufacturer and say, 10,000 people pre-ordered it, we need to buy 10,000 of those things. Or 2 people pre-ordered it, we need to buy 2 of those things. So they're doing it the right way over there in order to make sure that they don't go broke or take a bet on something that people don't necessarily want. And this has always been the challenge with new products. If you were getting a mold or getting machined parts, you have to buy the mold and then you have to get all those machined parts. And in order to make them cost effective, you have MOQs, minimum order quantities, that you have to order in order to get the price down to where it's economical for your buyers. And this is something that Simone is coming up against too. Her clothes hangers as currently designed are quite expensive. You can buy a set of them where they're about $10 per hanger, but they're really well made. They're a nice steel rod, and then they have the hinge on the in-between, so there's extra functionality from just a little wire hanger that you would get at a normal spot. So they're a good product, but they are also a premium product. And that's partially due to the volumes that they have to deal with. If they could scale it way up, then any part that is scaled way up generally reduces down near to the cost of the raw materials. But when you're still getting started, that's not really doable. So the question is, do you lose money or do you charge a little bit more in order to be profitable? Simone seems to be in between the middle there. So far in the middle that she states that she's pretty much losing money almost every single month right at the moment until the thing scales up and she's able to hit break even. Now, how could we help with this? Well, there's a number of ways we could help with this. This is actually the reason that Slant 3D was kind of started. With mass production 3D printing through print farms like ours, you don't have minimum order quantities unless you're ordering large batches. At that point, we do say you gotta order like 100 pieces, but 100 pieces is not a large volume. Or you can connect into like our print on demand applications like Etsy and Shopify, so that when an order comes in, it is printed and shipped out. That eliminates warehousing, that eliminates MOQs, and it eliminates all the fulfillment work that you would have to do if you ordered a batch of stuff and then had to ship it out the door. So all of those costs of running a business, all those fixed costs if you're doing it yourself, become variable costs based on the amount of demand that you have. If no one buys your product, you are not going to get billed to make that product. So you don't have to spend money in order to make money. You make the money and then you spend the money. This is really the joy of 3D printing in this regard. But now the question becomes, can you design a clothes hanger the way Simone did with 3D printing? Now, this was a quick knockout where we were proving out the concept. This would need to be refined more, but it is a good starting point. So Simone's hanger, the key differentiator of it is the fact that it folds. And it folds with a steel rod so that you can put a shirt on it, fold it sideways, and then hang it up against the wall just like this. There's a number of challenges when doing this with 3D printing. First of all, is it tough enough? Well, generally people would say, 3D printing, you can't make a clothes hanger out of that. Yes, you absolutely can. The trick is to make sure that you're printing it flat on the build plate, which means that you have to condense it. Now you could either fold it over flat like this so that it's printed horizontally, which we actually did, but we really didn't like the look of it, and having it print fully flat across here would have whatever is being folded into it be pinched and squeezed in a way that really wasn't useful, and you'd end up having something kind of closed partially like that because you have t-shirt balled up inside of there. So what we did was we put this arm straight up in the air in the design. Now, if you're printing straight up in the air, if you're doing it with a normal ring like this, now you did just make a cruddy part where somebody could knock this against the wall, and since the layers are going this direction, they break off. But what we did in order to reinforce it is you have this side down against the bed, you don't have a rib inside of there in order to minimize material, and then on this side, you do put a rib up here, a very small, thin membrane that allows you to get the strength that you need. This is not gonna break off, and I can squeeze it and beat it and twist it, and it's not gonna wear out because there's a nice, strong shear plate right there to make sure that these side parts cannot bend so much that they break. Now, the hinge itself, like I said, we can't hinge at the same point because it ends up creating a pinch down there where your thing gets in the way and then it only closes partially, which looks a little bit gross. So what we did was actually create a hinge where the hinge point is up a centimeter or so that it bends around that, and now you have this nice parallel fold where they're side by side. We did put this center support inside of there. We're not necessarily sure if that's necessary. We think we can probably redo the hinges on the ends so that they're more minimal and you use less material, because even though this is filled up with fairly low infill, because all the strength of a 3D printed part is in the walls, this allows you to make sure that it's totally beefy and really has no compressibility right there. But ultimately, it was just a proof of concept with this first couple of designs. The other thing we added on here, since we're doing 3D printing and we could do whatever geometry we want, we added a few resistance bumps up here to make sure that your shirt doesn't slide off too darn easily while hanging here at this kind of odd angle. But overall, that solves all the functional necessities of what Simone was going for. Now, this yellow hanger is not one that Simone would want to put onto her video. The Yetch store has a really nice aesthetic that is very hard woven, guy with beard sort of a brand, to where it's meant to be steel and wood and kind of premium materials. This doesn't look like premium materials. This looks like something you get at a dollar store. What we would do in order to address that is that it would be possible to print this either in a blacks or browns so that it has the correct aesthetic. We could change the geometry to make it look a little bit more rugged rather than plastic hanger, or we could even go so far as actually printing it in wood itself to where you have a true wood feel and look to it. So there's a way to change the cosmetics of a 3D printed part so it looks really good. And of course we could texture the outside to give it a non-layer lined look so you could get a really premium product out of this, especially if you were doing print on demand. So hopefully this is an idea that can help Simone solve the problems over there with the Yetch store and help her to scale up and get a successful business going over there. She doesn't necessarily have to use 3D printing, but it is an option that is available that many people don't realize. Printing can produce at scale. If she has 10,000 orders tomorrow, those can all be printed and shipped within a couple of days. That's what we do. It is feasible right now. So long as she's able to design a product that can be printed, and we've given a few of the baselines of how to get that done, then she can eliminate the problems of the upfront costs, the long-term storage costs, and the R&D costs, because she can just order a new one every time or print them at home to figure out the prototypes and then make the final refinements to make sure it's good for our process, and then just roll with it. So rather than creating 1.5 products a year, she could be creating 1.5 products a week, or maybe even a day, depending on how fast they want to go. It eliminates all this risk of having to swing for the fences and make sure that your product is right on the first try, and instead makes it more iterative to where you can try what might work and then move on to something else or refine it over time. So Morley Kurt recently made a video where he designed a stand and some luggage wheels for a OneWheel. But basically what he does is he tells a story about this problem that he had with OneWheels, and basically the fact they are just really heavy. They are a motor and a bunch of batteries stuck together, and the only way of transporting it when it's not transporting you is to carry it around. Morley runs through this in the case of a grocery store where he has to either throw it into a cart or lug it around. So he comes up with the idea of basically putting luggage wheels on the OneWheel and then also giving it a kickstand so that you can park it in certain areas standing vertically so it doesn't take so much room inside of your apartment, which are all great ideas. And then Morley shows the process of iterating through the design of this, of how to mount this thing up to the board. But when he finishes, he comes up with a design that is a little bit short of manufacturable if he wanted to put it in production with mass production 3D printing. So we thought we would go ahead and just run through the list of how to make a fully final and manufacturable version of his OneWheel stand with mass production 3D printing and print on demand. Now, the biggest issue that Morley ran into in his video was the fact that he had to use very expensive material. The material he actually ended up using was a form of nylon that cost $100 a kilogram. When you're making something like this, $100 a pop might be a little bit much, even if you can reduce material by cutting it in other places. It's much better if you can use a lower grade material that is more reliable and more stable, because you also don't know if that really expensive material will continue to be available. So we decided to go ahead and go on the premise of we're going to make this with PETG. PETG has good outdoor resistance. It's a nice durable material. It might be a little bit weaker than the Uber carbon fiber nylon that Morley was using, but again, cheap. So it can actually be mass produced. You can produce this for a few dollars rather than a few dozen dollars in the opposite case. But in order to do that, the first place you need to focus on is the flap. Morley ended up using basically just a single peg leg, which is fair and decent, but then he ends up having to have support on it. Removal of that support can really increase the cost of a part because somebody has to look at it and peck at it. Plus, you're also wasting that material. Why not integrate that material into the actual part itself? By using a chamfer on the underside, you add more meat to the flap so that it blends into the OneWheel better. It is stronger because there's more meat there, and you eliminate the need for support. This can print right here vertically, and you don't have any need for support anywhere. And you get to use what was otherwise wasted material in the actual finished part. So you've reduced the cost while getting so much more benefit out of it. Another place of reinforcing this hinge is rather than having it just be freestanding, go ahead and put a small rib on the inside there. That is not going to be a problem when you're using this because it doesn't interfere with the wheels or anything else. But again, it reinforces this main part. So just a small strut, and you don't have to worry about through holes or anything. You can just blend this all in because with a 3D printed part, we get to use infill. Infill reduces any sort of large amount of material that would be used because all the strength is out in the skin anyway. 3D printed parts are a lot like I-beams. It's the center rib that has all the strength and the two outer flanges, and you don't need a solid bar of steel in order to have the same strength as an I-beam. The same applies for 3D printed parts. The other thing we did to optimize this a little bit more and to reduce part count, because parts increase assembly time and assembly cost and inventory hassle, all of this stuff. We went ahead and just merged together the center aisle. Morley had two separate pairs right here, which means that again, he had a lot of wasted support in between and a lot of wasted strength that would have been available. By blending that together, that enables the rib on the side, and it ensures that you have fewer parts, because now you just have a single through rod with nuts on the end, and now you can mount up these wheels much more reliably with fewer parts and pieces. Now, those are the design optimizations. Now, what would you do about the actual business model of this? Morley is a YouTuber who has just invented a thing, and now the thing has been refined for him. Now he's got to start selling it. How would he do that? So in Morley's case, what he could do is he could create a Shopify store, and then he could connect to our plugin, or the other option is that Morley could order 1,000 of these and then sell them off over time, but then he has a big old risk of having to buy 1,000 parts of inventory, and Morley is a van lifer, so he doesn't really want to store up a bunch of stuff. But he could go the print-on-demand route, and he would never have to look at any of this. And quite frankly, one-wheelers could also just buy this hardware off of Amazon or something along those lines and just buy the plastic parts, and then we would print and ship those. So there's a few different directions of getting this done. Now the question is, why wouldn't they just go with normal production techniques? Well, this type of a design can't actually be produced with traditional manufacturing because it's too chunky. It would shrink with all these thick walls on there. So you end up having to cut ribs into it, and then you have these open sides and it looks really gross. Or you have to stamp it or carve it out of metal, and now it's really expensive again. So 3D printing is a really good way of making this type of really functional and durable accessory because you're able to get a nice chunky design that has a lot of structure and reliability to it without a lot of cost cost. Not to mention the fact that at any time, once we get customer feedback on this, the design can be readjusted again and improved, so that rather than being stagnant and literally cut into stone with a mold, it can actually be changed and evolved over time, so that your product gets better faster than anybody else would ever develop it, especially if they wanted to try to run with molds. So now you get this really heavily engineered and optimized part that has never been possible before, but it can be produced on demand and delivered straight to customers in a few days. Morley's video came out about September 15th, and we had finished this design about 7 days after that. This is innovation at the speed of thought. New products can be created so quickly and put into production because now there's giant print farms available that can produce it. Scott John is a fantastic industrial designer. He's based up in Seattle. He has done some great work. Even if you don't like Apple products, you have to appreciate what he has done around creating these accessories for Apple products. He does a video very intermittently, and they're always beautiful cinematography and beautiful product design. And I cannot say enough good things about the guy. He does great stuff. But today we're going to talk about the iPhone DN40 dock. So this dock is just fantastic. Like I said, you should go watch his video. But this was a product that is meant to be a standby stand for iPhone, because iPhone, when you put it into standby mode and it's charging, it goes into basically an alarm clock mode where you can get just basic notifications across the front screen. And this applies to a lot of other phones too. Scott loves the iPhone, that's okay. But the design of the stand is such that you're able to place the phone into it when you're going to bed. It mag-safes onto the stand itself. And then in the morning, you just pop a little button on top and the phone pops out and you grab it. It is a beautiful piece of product design, and one that I would love to talk about more context around industrial design, because Scott doesn't really explain it very much outside of, he wanted to do this. He did make it with overwork, where they wanted to create something that was reminiscent of old bronze style design that's very simplistic, based off of Dieter Rams and all the rest of this stuff. And the industrial design of it is great. It does a lot with very little. The function of it is fantastic. The experience and the ambiance of it is great. I can't gush too much about this because I really like this style of design. And this style of design is very enabled by 3D printing, because they were able to print in 2 pieces something that would normally have to be assembled in 5 or 6 different pieces if it was made with traditional manufacturing. Having to sandwich together the top and the bottom and the place where the watch goes in and all the rest of that stuff. Much of that is unmoldable as it is right now. But with printing, they could mass produce that product in a giant print farm like ours and not have to worry about the geometric constraints of it all. But there are some steps that they could have extended it further. The design of it as it is right now is okay. It is 2 separate pieces. You have the push out button, which is dropped into the top, and then you have the main body itself. Obviously, we're not printing the MagSafe chargers in any of this thing, so those would always have to be assembled down the line. But as to the design itself, it is designed to be printed up vertically with a little bit support underneath the ridge where the push button comes in. Now, if I was redesigning this product, I would try to find some way of printing it on its side or redesigning the push button to basically hang in the top slot so that it could be printed in place. This takes a lot more refinement and a lot more design optimization than they maybe had time to do, and you end up potentially with less crisp parts. The design of print in place features always relies on how well does a top layer fall onto a bottom layer and still have a smooth motion to it. It can actually be quite challenging, and there's a lot of things to have to be done rather than simply modeling the part. But if they were mass producing this, while all the pieces could be fitted onto one bed, it is better if you can aggregate all the pieces into one single file and one single print. So if that push button could have been redesigned a little bit more in order to be printed as part of the main body, that would have been better. The other thing that I would recommend is that the design overall is perfectly set up to hide the fact that it's 3D printed. Many people don't like 3D printed layer lines, and that's a little bit incorrect because layer lines are very much like grain in wood, and many consumers really do not mind the layer lines. This is a stigma that exists mainly within the industry itself, not really within normal consumers themselves. 3D printing is not a bad process, it's simply different, but people consider it bad. That all being said, if if you do not want the layer line texture, which Scott opted to go with in his video, you can actually apply something that's called fuzzy texture to the outside, which is effectively noise. This gives it kind of an orange peel kind of a look and can hide the layer lines very, very well. But the other option you can do is actually to CAD in this texture itself. You can put all kinds of slots and wobbles and swirls or whatever else it was, or even project the orange peel onto the part. This makes your STL really large, but again, creates a texture that hides the layer lines in it. From a business model standpoint, this is a fantastic product because this is an item that adds value to an existing item that people are already fans of, and it also shows a deep understanding of that item. You've got an iPhone in standby mode. What is a really cool case that we could create for that iPhone? Well, this is a really cool case you could create for that iPhone. It could be created affordably and it adds a lot of value. There might be an addition where they can make to it to where after the phone is ejected, something to cover the front face of it, because it's not very pretty when there's not an iPhone inside of it. But beyond that, it is a great object. And accessories are always great objects to go at because 3D printing is able to create new accessories very reliably. It's able to create tons of different variations. It's able to rapidly address a new item. So as the new iPhone comes out, you can redo the whole case and start printing them out. So it's a much more efficient way of making accessories than traditional manufacturing methods where you make a bajillion of them, ship them over here, store them, and tell people buy a few of them, and then you scrap them when a new phone or item comes out. Accessories can be made much more efficiently with 3D printing and still done at scale thanks to giant print farms like ours. And accessories tap into a niche, a group of people who really love that particular item and are looking for a particular accessory. The same thing applies to things like the Vision Pro, which are very specific and didn't have a stand for it to keep it from pressing its cushions down. This is another accessory that is very popular and has made a bunch of money for the people who created them. But ultimately, what I just wanted to do with this video was really talk about how great the design of Scott's item was. That iPhone dock is just a wonderful piece de resistance of how to create an object that is beautiful, reliable, and very functional for another object in your life. And it's all enabled by 3D printing. Its design is too complex to be made with traditional means, but it has an aesthetic that leans into what 3D printing can do. And if they ever wanted to sell these, there are now the resources available to mass produce these items with printing exactly to the amount of demand that the fan base demands. So this is a great example of a true product that could be created from this, and just an excellent demonstration of how to design for 3D printing to create something that people can really love and connect with. And Scott has always been really good at this with all of his videos. Again, one last time, I recommend you go watch that video and several of his other ones. Even if you're not into 3D printing, the cinematography alone is a fantastic thing. Scott is a fantastic artist who knows how to make something within the limitations of what he has available. And 3D printing is a different way of making stuff, so now you can make different stuff. If you want to check out other videos, we do a lot of these videos where we break down other designs. We've done Mark Rober. We've talked about real 3D printed products that are moving hundreds of thousands of pieces out there in the world through our real 3D printed product stories. And other than that, please like and subscribe. Have a great day, everybody.